This is 8.7, day 1. We're going to be graphing radicals today. So we need to know what each of these parent functions look like. So I'm going to draw a super basic example up here. Okay, x squared, remember, is the quadratic. This is the parent. Okay, square root of x looks like this. Okay, x cubed. Oh, sorry. I guess I have a spot for this. Sorry, I'm getting ahead of myself. I have a much better position for this to look at. Okay, you can always plug in values for x too as well. So if I plug in like 1 for x here, I'm going to get 1, right? So 1, 1. If I plug in -1, I get that. And then this, remember the quadratic has the pattern 1, 3, 5. So up 1 over 1, then up 3 over 1. And then up 5 over 1. And then connect. So the domain and range for the parent function, the domain is all reals, and the range starts at 0 and goes up forever to infinity. X cubed, okay, also has the points 0. And then the next one, 2 cubed, is 8. So -2 cubed is -8. So this one looks like this. So this is the parent function for x cubed. Domain and range are both all real numbers. Okay, so remember transformations. This is a vertical stretch or compression. Okay, this is left, or I'm just going to say, we'll say this, horizontal shift. And then K is a vertical shift. So we're just going to use our transformations, you guys, to figure out where these graphs are. Okay, so this one is a reflection over the x-axis. This is going to be left 3, and this one is going to be down 1. Okay, so we're going to take our parent function from up here, and I'm going to do these transformations, okay? I want to go in the order in which I would do order of operations. I want to go left 3, then reflect, then down. So this is 1, 2, 3. Okay, so my points here, again, I'm going to, so this is the parent function. Okay, so I am going to go left 3, 1, 2, 3, reflect, and then down 1. This guy, left 3, 1, 2, 3, reflect, down 1. This guy, 1, 2, 3, reflect, down 1. Okay? And this one is still going to have that pattern of 1, 3, 5, but we can do the same thing with those guys. Since there was no additional stretch, it just reflected, it's going to have this open at the same width, and it's going to still have that pattern of 1, 3, 5. So this is our new parabola. So the domain here is all real still. But the range now is from -infinity, and it goes up to this y value of -1. Okay, this one, the cubic function, is our parent function. So I'm going to take, again, my 3 parent function points. Okay, and I am going to move those in this fashion. So this guy is going to move right 1, and this is going to stretch. Now, specifically, it's going to multiply y values by 2. That's how it's going to do it. Okay, so let's do this. So 0, I move right 1. My y value there is 0. Multiplied by 2 is still 0. Okay, right 1, multiply by 2. So right now it's at 1, multiplying by 2 will move it up to 2. Okay? This point, right 1, I'm at -1 for the y value, so multiplying by that 2 makes it a -2. Okay? These ones I don't think I'm going to be able to fit because multiplying by 2 is going to change it drastically. So right 1 multiplying by 2 would put it way up here. So these are really, really steep. Okay, so my domain and range here is still all real numbers. All right. Okay, so now we're going to look at the parent functions square root of x and cube root of x. Okay, so again, I could put in values for x here. So if I put in 0, I get 0. Other nice numbers take the square root of. Put in 1, I get out 1. Put in 4, I get 2. Put in 9, I get 3. Now, I cannot put anything negative in here, right? Square root of a negative does not exist in the real numbers, so this is our square root function, okay? The domain is -infinity to, it's not -infinity to infinity. It starts at 0, and it goes right forever, so it goes to infinity. The range also has nothing down here, so it also starts at 0, and it goes up gradually towards positive infinity. Now, cube root of x, okay, cube root of 0 is 0. Cube root of 1 is 1, but I can take, I guess I'll keep going positive, okay? Cube root, another nice one to take cube root of is 8. Cube root of 8 is 2, okay? Now, I can take the cube root of negative values. Cube root of -1 is -1. Cube root of -8 is -2. So this one kind of actually looks like the cubic function, but much flatter. It's the inverse, okay? All right, so we are going to, and the domain and range is also all reals, just like it is for the cubic function. All right, so cube root of x parent function, square root of x parent function. Okay, these still do the same thing. Stretch or compress. This horizontal and this vertical. Okay, so here, this one is going to move left 1 and down 2. Okay, so parent function, I'm going to put those original ones. So we had 0, 0, 1, 1, 4, 2, 8, 9, 3. Okay, so there's my parent function. We're going to go left 1 and down 2. So left 1, down 2. Left 1, down 2. Left 1, down 2. Left 1, down 2. Okay, so there is my new graph. So my domain now has shifted over to -1 because of that left one. The range has gone down 2, so it's my y values start at -2 and go up to infinity. Okay, this one is a reflection. This one is going right 2, and this one is going up 3. Okay, so same thing, we've got our original points. So I'll use my same 3 big ones. Okay, so we are going to go right 2, 1, 2, reflect, and up 3. 1, 2, 3. Okay, right 2, 1, 2, reflect, and then up 3. 1, 2, 3. Right 2, 1, 2, reflect, and up 3. 1, 2, 3. So this one, because of that reflection, it's going in that opposite direction. My domain, my x value it starts at is 2. Oh, positive 2. And the y value it starts at is actually negative infinity, but it goes up to a max of 3. So the range is negative infinity up to positive 3. Okay, let's see. I think I might have a couple more here. Yep, 2 left. Okay, cube root of x. This again is a reflection. So cube root, we initially had these guys, and then 8, negative 2 is kind of my other big one. Okay, so there's my parent function. This one is going to just reflect over the x-axis. So this one stays, this one goes to here, this one goes to here, this one bumps down here, this one bumps up here. Okay, so still has the same kind of shape, but now going from left to right, it's going the opposite direction of where it was. And we know any cube root function and cubic function, our domain and range are both going to be all reals. Okay, another cube root. Okay, this is right 2, multiply by 2, and then up 4. Okay, so put my parent ones in here, you guys. Okay, so each point, so 0, 0, right 2, y values by 2, right? Right now my y value is 0. 0 times 2 is still 0, plus 4. Okay, this point at 1, move right 2, 1, 2. Multiply the y by 2, so now I'm up at 2, and then add 4. 2 plus 4 gets me up here to 6. Okay, negative 1 moves right 2. Still at negative 1 times 2 is going to go to negative 2, and then up 4 puts me at 2. Okay, here I'm at 2, go right 2, multiply by 2, so that gets me to 4, and then up 4. 1, 2, 3, 4. Okay, this guy, right 2, negative 2 times 2 is negative 4. Add 4 puts us up at 0. All right, so here is our cube root function after those transformations. All right, so we have a domain, again, of all reals and a range of all reals. All right, guys, that is it for this graphing video. Thanks for watching.